Hello and welcome to Microsoft Mechanics Live. Coming up, we're going to explore 3 real-world and recent attacks in detail and how they worked on the platform defenses in Windows 10 to both block and mitigate against them. From containing spear phishing attacks to defeating and targeting intrusions using macros and investigating possible breaches and containing those. We're also going to look at new approaches for virtualization-based security to isolate malicious code, credentials so they don't go into user mode, and also code integrity policies and more. And we're going to show new forensics tools to be able to investigate, contain, and fix anything that might come in post-breach. And to do that, I'm joined by the man, David Weston.
Hello, everyone.
Give him a round of applause.
Thank you. Thanks for having me on the show.
He's from the Windows security team doing all of the forensics and things to actually look at malware as it comes in. So your team's actually responsible for the R&D of the tools to protect, but you've got to be very close and uptight with all of these malicious kind of pieces of software coming in and things like WannaCrypt. We've seen ransomware, NotPetya, WannaCrypt, and other things recently. It's becoming like a household set of names of technology that, even when I go and visit people, relatives, on the holidays where they don't even know anything about computers or how to turn them on, they're talking about WannaCry and these types of things.
Yep, absolutely.
So it's a whole different world now. Let's dive into a few real attacks, though, and the defenses that we have in Windows 10 to be able to stop them.
All right, to make things a little bit real, I thought today that I would show you what ransomware looks like in practice. How many of you have run into a ransomware attack previously? All right, so some folks, unfortunately, familiar with it. So what I'm going to show you is a machine, very much probably like your own, with a few sensitive documents. We've got an immigration form here. We've got some taxes, an important presentation. And of course, we've got wedding and baby photos, the kinds of things we don't want to have encrypted or stolen from us. Unfortunately, we've got an email about a payment past due. Of course, we're all responsible financial citizens, so we want to understand, hey, what's going on with this? So we click the link in email. That launches a URL. This URL asks us to open a document, hopefully describing what's going on with the payment situation. Oh, look, I can't actually see it unless I enable editing. That's what the document's telling me.
Just to pause you here for a second.
Sure.
Because and being in marketing and coming from Windows, you can even tell by the branding and the Office logo and all this old stuff from Office 2007. These are usually kind of telltale signs that something bad is going to happen here, right?
Absolutely, and there'll be sometimes, a bad grammar, maybe an off image. Those are actually pretty good indicators that something's amiss.
Right. So what are we going to do? We're going to use some isolation or something to be able to prevent this from happening in the real, kind of in a Windows 10 system?
So the first thing I'm going to show you is what it actually looks like. So you can see here, macros are disabled, which is a good thing, but the document is saying, you can't view me unless you enable it. So I'll go ahead and do that. And just to make it real, what's going on there, you can see if you sort of zoom in there, that there's an executable called bad running now. If we wait just a few seconds, what we're likely to see is our precious documents, our photos, and a few other things. And you can see it's sort of chunking along, it's reading. Defender and other AV is starting to pop up now. Now, I've purposely disabled some of that stuff. But you can see right away the Cerber ransomware is actually asking us to go and purchase some Bitcoins in order to pay the ransom here. It's asking us to get the Tor browser and get on an anonymous part of the network to pay this. Actually, they're probably our most robust piece of documentation is how to pay. They never sort of miss that. And you can see all of our documents now are renamed and encrypted. So pretty bad day. Now,
so what are we going to do then to stop something like this? So you've got this, luckily, in a very isolated virtual machine that can't infect your host.
I do.
How do you protect this from running on another machine?
So one of the things we did in the latest Fall Creators Update edition of Windows 10 is we introduced a new feature that we call Exploit Guard. And Exploit Guard has several powerful features for preventing ransomware. One of the features in particular allows you to say, I'm okay with opening macros. Maybe I need one for work, maybe I need one for a financial application, but I don't want those macros to inject code, create processes, write processes onto the machine. So what we're going to do here is very simply, and of course this is all available through SCCM and MDM and other tool sets, is we're going to add a couple of these rules, and if the demo gods comply, we're going to be able to set those rules. We're going to run the exact same macro, and we should see a block message. I don't know.
So this is like at a previous checkpoint now running the same code?
That's right. sorry.
But with the right configurations applied.
That's right. So something's funky going on with my PowerShell, so I'm going to relaunch this at admin. Again, these are the same kinds of rules that would be available through your management system. I'm just going to type them in here for ease of use. So we'll go ahead and type the clipboard in there, and we'll add the first rule. This first rule is saying no macros should be able to create executables. I'll run that one more time. And the second one is saying no code injection from a macro. So again, we'll have the clipboard type that in, and we'll run that. Now we'll run the exact same demonstration now, and we'll see if everything works out. So this time we'll go again and click that attachment again. Of course, it's asking us to run the document.
So, okay, so we got the
enable the content.
What happens? Oh.
And bam, there you go, action is blocked.
Very
so
cool.
That's pretty cool. This is a great feature. Of course, I'm going to show you in just a minute what that looks like to investigate something like that, but you get auditing rules, you get that information, so it's pretty great.
And again, you could have used group policy object, you could have used CSP and MDM, all of these different things to enforce that rule set.
Absolutely.
Okay, so we've done some cool things in terms of preventing the code from running in the primary user session, user mode.
That's right.
And we can do more of that in terms of basically isolating where browsers run as well, because a lot of the threats that we're seeing are coming in via the browser. Can you show us another real-world example of one of those types of attacks?
Absolutely. So what you see on the side here, this black command terminal, is actually Metasploit, which is a common attack tool that people use to audit their networks. So I'm going to simulate being both the victim and the attacker in this situation. So what I'm going to do is I'm going to run my exploit. This is going to give me interactive control of anybody that clicks a link. This is actually a simulated 0-day. So what will happen is, if everything goes well, when the exploit runs, we'll get a callback. It'll say, you now have control of the machine, and we can do things like dump credentials, pass the hash, take screenshots, etc. But I think there's a surprise in store for the attacker, so we'll run that. So what I'm going to go ahead and do here is now actually run the exploit. So exploit setup, it's now waiting for everything. On the VM here, which is our simulated victim environment, what's actually being run is a future feature that we're releasing in the Fall Creators Update, and it's a version of Microsoft Edge that's contained in a very tiny hypervisor. If you're not familiar with hypervisors, the way you can think about it is we took the entire operating system and we squeezed it down into an 18 megabyte image, and we tailored it specifically for Microsoft Edge. And what that means is no matter what happens to the browser, excuse me, it's actually contained against the hypervisor, so if an attacker gets into your browser, they can't tamper access credentials, access your documents, do any encryption. And what I'm going to simulate here is a real-world attack that many sort of potentially state-sponsored or targeted attack groups would perform, which is sending you an unassuming link that you click that redirects you to a site containing a 0-day exploit.
Okay, so let's see it.
Simulate that here. So we've received, again, a link here that says click the prize to redeem. We're going to go ahead and click that. It's going to launch in the container.
That looks pretty bad.
And what you're seeing on the left-hand side here is we got an immediate callback. So 0-day exploit's been successful. This is both a 0-day exploit in the browser and even a kernel exploit. So full control of a standard host at this point. But because we're in the isolated environment, let's see what the attacker can actually do. So give it a second. Now we'll interact with our session. So again, this is a interactive session with the container. So we can say, if we call getUID, we're actually NT system. So we got full control of this. Pretty scary.
That's pretty scary, scarier than that photo.
So let's go and see what kind of data might exist on this machine. So we'll change directory into users. We'll hit dir. Interesting thing here is, even though this looks and feels like my browser, I'm actually running in a separate environment. So the attacker is going to bum out container user, container administrator. Those are credentials and accounts that only live in this virtual disposable world. And as soon as I close this browser, that $500,000 exploit is gone. So let's try to run Mimikatz. How many of you are familiar with Mimikatz, the credential theft tool? I see a few folks out there. So we'll run the classic Mimikatz. We want to steal credentials. Let's see what that looks like. So we'll say help here, and we can see there's a bunch of commands we can run. So let's steal a Kerberos cred. So if we run Kerberos, we're actually dumping memory. Unfortunately for the attacker, all they're seeing is, again, container accounts. So we have application guard utility account, container administrator, et cetera, et cetera. So what we have here is really the type of exploit that would have, in previous generations of isolation, compromised the entire machine. Something that might go for $500,000 on the open, sort of black market here, and we've stopped it by simply running things in a virtualized environment.
How about that? So the really great thing is that we're using isolation effectively, and we're using kind of containerization technologies to some extent, like we saw there, but we're also using isolation on the flip side in terms of doing things like code integrity policies, credential guard, keeping credentials out of main user mode, and device guard, all those types of things, all the guards going into an isolated virtualization-based security environment. That way it's not talking to the main user mode and not being able to kind of impact the code that's running, steal the credentials, or in this case, exploit the browser, because the browser in this case is in another separate container, completely isolated from user mode. So I know that sometimes though, things do make it through, and we like to live in this kind of post-breach world, post-breach mentality.
Absolutely.
What do we do if something comes in and actually is successful and breaches our environment? How do we detect that, and what are the tools available for us there?
So Windows takes an assume breach security philosophy, which I think is a very modern approach given the type of sophistication of threats out there. So we built Windows 10 from the ground up to have sensors inside of the operating system fabric that give us all the information we need to detect, diagnose, and now with the Hexadite integration, which we've talked about this week, automatically respond and cleaned up those threats. So what I'm actually going to show you here is a repeat of the two attacks you previously saw, but what they look like from an ATP perspective. So let's start with the macro attack. What we can see here, by simply filtering the exploit guard events, and this is information coming off of that victim machine, we can actually see exploit guard blocked, creating the child process bad.exe. If we click on bad.exe, we can get a perspective on how malicious this is. Virus total says 55 of the world's antivirus engines think this is bad, so probably a bad file. We can see Defender AV has recognized it accurately as Cerber, and we can also do things like say, stop and quarantine this file. If we'd like to pull it into the cloud to do further analysis, we can hit the submit button here. We can also see, does it exist anywhere else in my enterprise where I have Defender ATP deployed? And of course, we can also, in the forthcoming versions, automatically set the system up to respond and clean up those ransomware threats before they become a problem.
Very cool. So one thing to point out here, and I'm not sure if this is something that's aware of kind of things that you can see through the demos, but you couldn't actually just bolt on some of this technology, even if you're using a hypervisor, you've got something else running. There's no way to kind of do those platform-specific changes that we've made where you've got credentials, code integrity, or you've got other apps running in an isolated container environment. These are all Windows 10 fundamental things that you just couldn't bolt on, right?
That's right. I think one of the novel things about Defender ATP is it's not an agent. It's not some piece of code that we added as an afterthought. What we actually do is we sit down with all the key Windows engineering teams and we brainstorm together what would be the best way to alter the code of the operating system to get us the information we need about attacks. And we use red teaming, past experience, analysis of real-world attacks to pinpoint those places in the operating system that would be most beneficial to collect data, and that's sent into the Microsoft Cloud. Combined with the intelligent security graph, we can run behavioral analytics, indicators of attack, machine learning algorithms, and that's how you get all these awesome events that can tell you what's going on. So if we now zoom into the second attack, which is that zero-day attack in the container, we can see that Defender ATP recognizes this as in the container. So if we look at the timeline here, we get a little indicator that says this is activity that's in the container, and the entire machine timeline, both the host and container events are together. But one of the things that it's uniquely identified is there's been a process privilege escalation. And what we've done here is we've used an anomaly algorithm to identify that Microsoft Edge went from the lowest sandbox privilege level all the way to system, and that should never happen in a real-world environment. So we've picked up on that. We can see that the kernel has been spotted having an access token modified, so there's actually been some kernel data corruption. This is a bad day from a normal perspective, but with Defender ATP, we can immediately identify this, make a plan of action, take additional automated actions on the machine, like investigate it, collect additional forensics logs, notify our teams, and most importantly, with the click of a button, we can use the host-based firewall to isolate that machine so that further damage can't occur.
So very cool. So we've seen some real-world attacks. We've seen how in post-breach, You can identify things with Windows Defender ATP, being able to not only investigate, but also contain and even mitigate, in certain cases, those attacks.
Yep.
So we've seen a great explanation of all the different things that were protected with Windows 10. Where can folks go to learn more about the security stack?
Well, the good news is there's been numerous talks about Windows 10 security here at Ignite, so that's a great resource. But I would say the best resource for learning how Windows 10 mitigates the latest attacks is the Windows Security blog, which is pretty easy to find, and we'll have the latest information on our products and what you can do with them.
Very cool. And if you're not on the Windows Insider program, you should be on that now.
Absolutely.
And you can also get access to kind of the earliest versions of these types of technologies. The application guard, for example, you can invoke that through the kind of through the settings dialog, like you could, for an example, in private browsing instance.
That's right.
So it's easy to start testing this stuff now. Thanks, Dave, for joining us. Great
Thank you.
overview.
Of course.
That's about all the time we have for this episode of Mechanics. We'll see you next time.
Thank you.